Welcome back to Year 10 Science. We're sort of getting towards the pointy end of this course now, on the home run. Only a couple more weeks and we'll be doing an exam and finishing up the whole unit. So today we're going to extend our understanding of ions into ionic bonding. Okay, and obviously if we are bonding different atoms together, we would form ionic compounds. Okay. So before we go too far, just have a think about how you're feeling today. Hopefully you're maybe this one or this one. All right, should be pretty straightforward this stuff today, so let's see if we can run with it. So what are we doing? We're going to look at ion formation in the periodic table and apply some conventions and start to write some ionic compound formulas. Remember when we spoke about ions, we were talking about an atom that gains or loses electrons, so it becomes either positive or negative. Because we have an atom that is positive and one is negative, they're attracted to each other, and that's the basis of this ionic bonding. When we looked at the periodic table, we saw that it was in those rows, which are the periods, and their columns are called the groups. So those vertical columns are groups, and in particular, group 1, group 2. Over the other side here, we refer to this one as group 3, 4, 5, 6, 7, and group 8 on the end there. These ones in the middle here are the transition metals, and we leave them out for this sort of discussion because it makes it a little bit easier to explain what's going on. Don't worry about the extra groups down the bottom there, the lanthanides, actinides, all those guys. Don't worry about them. They're sort of more the radioactive ones. How do we know they're radioactive? It's got things like uranium in there and so on. Now, the thing to remember here is group 1, which are our alkali metals. They're called group 1 because they have one valence electron. So they lose that one valence electron and hence end up with a 1+ charge. Group 2 does the same thing, except it's got 2 valence electrons, so they end up with a 2+ charge. Go over to the other side. Group 7 has 7 valence electrons over here, so it's easier to add one in there, so they will get a 1 negative charge. By adding 1 electron, they become like group 8, which is the noble gases, and remember, they're called noble gases because they don't react very easily with other elements. Hence, back when we were doing these things a couple of years ago, it was the nobles that didn't interact with the common people. The noble gases in that last column there don't really react with the rest of them very easily, so that's kind of why it was named that way. Group 6, if you add 2 electrons, you'll have a 2 negative charge, and that makes it like a noble gas. Group 5, if you add 3 electrons, you get a 3 negative charge. Okay. If we go back to group 3, those ones can lose those 3 electrons and get a 3+ charge. And what we're doing in all of this, it's like if we are in this column here, say we've got the boron or the aluminium or so on, we lose those 3 electrons. So if we lose 1 electron, it becomes like group 2. If we lose another electron, it becomes like group 1. If we lose another electron, where does it go? It goes all the way back to the start and becomes like the noble gases down the other side there. So everybody's trying to get a full outer shell of electrons, which makes them like a noble gas. That's what's going on with all of these reactions. It's all to do with those valence electrons, which are the electrons in the outer shell. Now let's ask ourselves, what did we learn last time? Last time we spoke about cations, which is a positive ion, and an anion, which is a negative ion. Remember the little way that we had of remembering it? Cation, like it has a T in it, which is like a positive ion. Anion has the N, which is like N for negative, which is a negatively charged atom or ion. And to become positive, we must lose negative charges to leave a net positive charge. That's the cation. And to become an anion, we must gain some negative charges to get more negative charges, because it's only the negative charges that move around. That's the electrons. So we gain electrons. We had a look at metal atoms. such as sodium, magnesium, potassium, how they lose their electrons, and the non-metals, which is like our gases and so on, that will actually gain the electrons. And sort of to explain how that's going on, like I showed you before, it's like everything from here across is going to lose those electrons and become positively charged. Everything from here across is going to gain those electrons and become negatively charged, so that they all have a full outer shell like our noble gases over there. Now this column here, group 4 in the middle, is a little bit different because you could almost think about, well, would they lose 4 electrons to have a full outer shell and become 4 plus? Or would they gain 4 electrons and have a full outer shell and become 4 negative? They don't really do that. They operate a little bit differently, which is what we refer to as covalent bonding, not ionic bonding. Covalent bonding basically means they end up sharing electrons rather than giving them up. We've been talking about the ionic bonding, where we actually give up those electrons and take on a charge or become an ion, hence ionic bonding. So let's look at some examples of that. If we have sodium, this guy here, and you can see that sodium has that 1 electron in the outer layer there. So if sodium loses that electron, this outer shell is now vacant, and hence we have a 1 plus charge, like it says down the bottom here. 11 protons, 10 electrons, so there's a net 1 plus charge. How do I know there's 10 electrons? 2, 4, 6, 8, 10. But its atomic number is 11, like it shows you in the middle there. So sodium becomes that 1 plus charge. Fluorine, on the other hand, over here, fluorine has 9 protons and 9 electrons initially, so 0 net charge. And there's that empty space that we've shown over here. We fill that one, we fill that outer layer, and we have an extra electron, so there's a net 1 minus charge. And that's what this is showing us. So this fluorine atom acts like an atom of fluorine with a 1 negative charge. The sodium, which is Na, has a 1 plus charge. The positive and negative are attracted to each other, and hence they will stick together. Sodium fluoride is what we end up forming. So predicting ions that we're forming. So we look at our periodic table and predict what actually happens based on those valence electrons. So it's a good idea to go and grab a copy of your periodic table and predict the ions that are formed. Where is oxygen on the periodic table? It's a gas, so it's going to be over on the right hand side, like fluorine. How many electrons will it gain or lose? What will happen to it? Things like sodium, magnesium, they're metals, so they'll be over the left hand side. What will they do? Neon's a bit of a funny one because that is a noble gas, so it pretty much has a full outer layer and doesn't have a reason to react. So think to yourself, is the element a metal or a non-metal? They are over on the left hand side, over on the right hand side. The metals will lose their electrons, the non-metals will gain electrons. Hence, the metals will have a net charge of positive, the non-metals will be negative. Think about something like argon. That's a noble gas, so it's not going to want to react. And that's what this is showing us here. Find them on the table there. If you're not sure where they are, just Google it and it'll bring up exactly where it is. But we have our gases sort of over there, and we have our metals pretty much that way. Okay, so just to recap on that one, something common like sodium chloride, which is table salt. We have a sodium, this one here, who gives up that electron in the middle there. It fills that outer shell of the chlorine. Sodium has the positive charge, and chlorine ends up with a negative charge. Hence, these two ions, or these two charged atoms, are attracted to each other, forming sodium and chlorine. But the sodium is the metal, the chlorine is the sort of the gas, the non-metal. Notice the ending that we added to it. Instead of calling it sodium chlorine, we called it sodium chloride. And that's just a convention on how we name them. But the common name for sodium chloride is salt, as in like table salt that you have on your fish and chips and stuff.
I always think that chicken salt's better than normal salt, but that's my personal opinion. Okay, so we've got a video there to check out and a little worksheet that's in the OneDrive that's attached to this if you've got that you can complete as well. So have a go at that one. The link's in the description below. And here's some more information I'd like you to watch. The first two videos are about ionic bonding. You really need to watch those and make sure you've understood exactly how ionic bonding is occurring. And that guy on those videos will explain it in his own way, but it'll be a bit different from me, and that's good because you want another perspective on this. I then want you to extend yourself a little bit and have a look at the type of bonding we haven't really discussed, and that's covalent bonding, and that's the bottom two videos. Have a check out that one. In the ionic bonding, we're giving up our electrons and accepting our electrons to form ions. In covalent bonding, we share them. Have a look at those. Thanks.
Have a look at this particular video as well. This one here, I'll put the link in the bottom as well. Goes through the same sort of thing that I've been discussing and shows you again how, in a different way, how we put these things together to form these ionic bonds to form the reaction. As I said, that video will show you the chemical formula for ionic compound, but there's other worksheets that you can have a look at. For those that have their OneDrive link, you'll find those in there. Make sure you complete that particular worksheet. Have a look at chapter review 4.2 and 4.6. Check those out. You have your textbook to work with. That's coming from the Jacaranda Science Quest 10 book. Check that one out. All right, have a think about what we learned today. We spoke about ionic bonding, how these ions form, how they give up an electron or accept an electron, become charged, which is an ion, and they go together because there's simple charge attraction. All right, what we're going to start talking about in the future is solubility, as in how we look at some of these reactions of ionic compounds. And sometimes when they react, they'll form a product that is soluble or dissolves in the aqueous or liquid water. And sometimes they're insoluble. We'll look at that next time. Okay, thanks for coming.